Okay, welcome again for the last session. This time I mean it, the last session in exercises, and we finish the whole chapter, okay? In exercise 4, we focus mainly on parallel connection. Previously, we solved series connection. Now we focus on the connection of lamps in parallel. The generator in the circuit shown in the adjacent figure delivers a voltage of 6 volts. The ammeters A and A1 indicate 600 milliamperes and 280 milliamperes respectively. Redraw the figure and add to it the directions of the electric current in all branches, the COM terminal of each ammeter, and another ammeter, A2, to measure the current through lamp L2. So we need to redraw this figure. Then determine the reading of ammeter A2. What are, listing the laws used, the voltages across the terminals of each lamp? Then what happens to lamp L1 in each case? To solve that, let's move on. So first question, we have to redraw the figure. Now, in order not to waste a lot of time, or you know what, I can do it directly. So we have a lamp, choosing my pen, okay. So we have the generator first. Connected to it is an ammeter, A. Then here we have ammeter A1, and the lamp as well. Okay, I need to fix this generator. Okay, it simply doesn't seem to be neat, right? Okay, so that's it. Now try your best to have the difference between the branches, the poles appearing. Another branch is, I will add an ammeter because I remember that they asked about it, and the lamp. So the lamps are L1 up, L2 down. Anything else? That's it. Now, the question demands adding the COMs. The COM should always be connected to the negative side. So here is the COM of the first ammeter, and this is the COM of the second, and this is the COM of the main ammeter. Okay? What else? Checking if I have answered everything. Showing the directions of current. I didn't show that. You remember that electric current flows in the circuit from positive towards negative. In the battery, it's the opposite, but we do not care about batteries now. So just add direction of current I. Reaching this point, it splits. Here it splits. Okay? And that's it, current I. Okay? That's all. Great. So that's it concerning part 1. We move on. Determine the reading of A2. Ammeter A2, which we added here, I can add it directly on the figure, has some reading. How much does it read? In order to answer these questions, always think of 2 ideas. First, am I given a value about reading of A2? Obviously not, since A2 is added to the circuit and we are not given anything about it yet. However, we are given the readings of A and A1. How can I link them together? Second point we talked about is look at the connection. How is the circuit connected here? How are the lamps connected here? They are connected in parallel. What do we know about current in parallel? Notice how the questioning happens. First, am I given anything which is indirect help? Second, I ask myself, what's the type of connection? Third, I ask myself, how can I benefit of this connection? على طول القصة هي ذاتها. شوف نوع الكونكشن series أو parallel ومن هنيك انطلق شو بدك تكمل. So over here we have part 2. L1 and L2 are in parallel, are connected in parallel. So directly what can I say? So current is additive. Okay? That means I equals I1 plus I2. Now, I is, let me go up, I think 600 milliamperes, but I'll double check. Okay? It is 600, yes. So I is 600 milliamperes equals 280 milliamperes plus I2. Some of you might be asking now, shouldn't we convert to amperes? Well, no, we shouldn't, because In the question, we are not given anything about units, about SI unit. So we can simply stick to it as milliampere and milliampere. What's essential is to have the same unit or order of unit on both sides. So they should both be in milliamperes or both in amperes. If you want to convert to amperes, feel free to do it. If you want to keep it as milliampere for the time being, for now, you can also keep it. Okay? So, I2 equals 600 over 280. I dropped the units just for now. I2 equals 320 milliamperes. Frame the result. I have finished this part and that's it. In case you are using amperes, it's going to be 0.32. Okay, now splitting my page here to continue with part 3. Okay, what are, listing the laws used, the voltages across the lamps? So the voltages across the lamps, how much are these? First, the lamps are connected in parallel. That's great. And they are also connected in parallel across these points here, which are also connected to the dry cell. So I can say that lamp 1, lamp 2, and the generator are in parallel connection. So they share the same voltage. And keep in mind, the generator controls the voltage. Anytime we have a generator, it is the control of the voltage. If its voltage is given, it stays that and like that throughout all the exercise. So, one more thing, we didn't mention anything about ammeters. We know that ammeters do not cause or do not affect voltages in particular because they have 0 volt. They take negligible voltage, right? So I'll mention that first, then I'll continue with the parallel thing. So first, note that ammeters take almost 0 voltage, okay? To be accurate, it's almost 0 voltage. In general, we just say 0, okay? Now, L1 and L2 are in parallel, and L2 are in parallel, and across the lamp, across the generator, across the dry cell. Okay, I'll erase these parts which are, okay. So what? So, voltage of the generator, UG, equals U1 equals U2, equals the generator's voltage, if I'm not mistaken, is 6 volts. Yes, it is. Equals to 6 volts, and I'll frame my result. Okay? So parallel connection demonstrated first for current addition, second for voltage unity. Law of addition of currents in parallel, law of unity of voltage in parallel. And notice I added the idea of ammeters taking no volts. Okay? We said before that ammeters and voltmeters do not affect the circuit. Adding this point here is just a quick refreshment of your, for your ideas. Part 4, the last part I think of this exercise. What happens to lamp L1 in each of the following cases? I like this question. Answer by mentioning whether it remains lit or not. So here we have the ammeter. It doesn't affect the circuit anymore. So we have the 2 lamps. In the first case, the filament of L2 breaks out and it turns off. The filament breaks out. When the filament of a lamp breaks out, it simply splits. So it becomes an open switch. When you have an open switch here, what happens? Definitely the lamp will not light. But what happens to lamp 1? Now, here is the misconcept. Obviously, no more current flows here, but the current will continue flowing through L1. No more voltage across the lamp, but there is some voltage across the wire. I don't care about that. The voltage across lamp 1 stays the same. Okay? The misconcept that usually people think about is the voltage remains the same, but more current flows through L1. That's wrong. The current in L1 remains the same. So keep in mind, guys, voltage is controlled by generator, okay, while current by device. So if this lamp, for example, in the first part we were given that it took 280 milliamperes, it will keep on taking 200 milliamperes. Now the generator's current will no longer be 600 milliampere. That will drop, will decrease, because no more current is flowing through L1 or towards L1. Okay? So, the filament of L2 breaks, 4-1, part 4, 4-1. Lamp L1, okay, continues to shine as it was, as it is. Okay, between brackets, no change in its current, no change in its voltage, okay, and the current it draws is the same, is also the same. Okay, so nothing changes for L1. In the second part, 4-2, L2 is short-circuited. I will draw this figure. I will draw this to discuss according to it. Let me draw it here. So I will just draw it without ammeters. I just need to focus on the lamps, yes? Okay, this is L1, this is L2. L2 is short-circuited. What happens then? Current, which is flowing here, reaches this point. You know, when the current reaches a certain point, where we have a splitting point, it will choose the easier path. Here, it is easier to flow through the wire. It is less resisting, as we said before. So all current flows here to the wire and continues. So what do you notice? Both lamps will turn off. Okay, so both lamps turn off because they are short-circuited. Short-circuited. Okay? Between brackets, figure. If you add a figure here, a reader would understand what happened. Okay? So this is a very nice thing. When you short-circuit devices in parallel, the whole devices stop functioning. Okay? يعني إذا أنت بالبيت جيت حطيت اوعى تجربوها بالبيت شي شريط كهرباء بفيشة بالحيط لأنه بالبيت الكهرباء in parallel. Yes? All electricity will flow through this wire. هلا هون الكارثة، هون المشكلة. The lamps هيدي كانت تاخد 280 ملي أمبير، هيدي أخذت 320 ملي أمبير. هلا the lamps are taking no more current. مين اللي بده ياخد أو يسحب كل الكرنت؟ It is this wire. وصدقوني it takes enormous wire. It takes enormous current. بهاي الحالة ممكن البطارية تفقع أو تحترق. كرمال هيك إذا هذا الشيء صار عندكم بالبيت، إن شاء الله يا رب ما يصير أبداً، either the wires will burn out أو إنه بتك الساعة والجنريتر بده يحترق. Now we cannot control the generator بحالة البيت. That's why بتك الساعة أو الشرطان بيولعوا literally. وكلنا سمعين فيها هالقصة. So short circuits are very dangerous. Pay attention to that. Okay? Now we move to the last exercise. Exercise 5, normal functioning of a lamp. Honestly, I took this exercise as it is, copy-paste from the official exams. هيدا السؤال جاي بالدورات. لنشوف نحن وين صرنا بالنسبة للدورات. In the exercise بنحكي شوي عن resistors اللي هو رح نحكي عنه بالشابتر اللي جاي. Yes, when I reach that point وعم نحكي أنا وياكم رح قلكم إنه هاي البارت ما لازم نعرفها نحن. Yes, but we'll see until now شو صرنا قادرين نحل من سؤال جاي بالامتحانات الرسمية. A circuit, the circuit of document 1, let me move to the other side first, consists of a generator G delivering across its terminals a voltage UAC 12 volts من هون لهون, resistor R, a resistor D of resistance R, هيدا الريزستور اللي عم نحكي عنه. The resistor takes electricity and gives heat. Okay? هيدا إذا بدكم تعرفوا شيء عنه مش أكتر. And a lamp L carrying the inscriptions 930. So the lamp carries the inscriptions 9 volt 30 milliampere. A closed switch K an oscilloscope connected across the terminals of the resistor D. Part 1, role of D. Okay? Part 2, exploitation of the waveform. رح نحكي عن شو طلع عنا على الجراف. وبارت 3 مثل comment, determination of the value of R. هيدا البارت اللي احنا مش مطلوب منا بعد. هيدا لنبلش نشتغل. In the first question, what do the inscriptions 9 volts and 30 milliampere represent? What do the inscriptions 9 volts and 30 milliampere of L represent? So 1, I, 1. 30V, 30 volt, is the rated voltage of L. Of L. أكيد L is the lamp ومعروف لسه. What about 30 milliampere? Is the rated current. Okay? Now رح حط نوت سريعة عنهم. Okay, in red. That means when the lamp functions normally, أكيد you can replace functions by lights normally. It draws a current of 30 milliamperes. هاي معناتها rated current. Okay? Part 2. If the lamp is connected directly across the terminals of G, it burns out. Justify. So voltage of the generator is 12 volts. Voltage of the lamp rated is 9 volts. So voltage of the generator is greater than the voltage of the lamp. So شو عندنا هون؟ There is a risk of burning out. عم تعطيها voltage أكتر ما هي بدها. So the lamp risks burning out. Okay? Now definitely using risking for the lamp isn't a smart choice. Okay? There is a risk for the lamp to burn out, but it's fine. Okay? Deduce the role of D. So, in your opinion, D, which we have no clue about yet, what is the role of D in this case? What for do we use D? Apparently, D is the portion of the circuit which is going to take part of that voltage. The circuit, the generator is giving 12 volts. The lamp needs 9 volts. Adding D, okay, so D may help reduce the voltage taken by L, thus protecting it. So without knowing what a resistor is, adding it in series with a lamp may help the lamp prevent the lamp from burning out. Okay? Again, this is something additional. When we study resistors more, we might talk about them more. So if you are able to solve 1 and 2, it's perfect. Part 2 now. Document 2 shows the waveform displayed by the oscilloscope. First, the term waveform just represents what you see on the screen of the oscilloscope, as you can see here. It's not necessarily a wave. It's a commonly used term. Given the vertical sensitivity is 1 volt per division, meaning each division here, each box is 1 volt. It's an easy sensitivity, by the way, and easy scale. Part 1a. Does the oscilloscope measure UAB or UBA? Okay. The oscilloscope, instead of answering directly, I will explain. As we know, the oscilloscope displays or measures or shows, any verb can be used, the voltage U, Y, com. Looking at the figure, entry is on A, so it displays UAB. From entry to com, or to ground, by the way, Here I used YCOM. It's the same as entry ground. Let me add this in different color to link ideas together, which is U entry ground. We talked once that we can use entry instead of channel or instead of Y. Okay. Part B. Calculate the value of UAB, the voltage. UAB, that's of an oscilloscope, yes? In volt equals Y in divisions times SV in volt per division equals 3 times 1 equals 3 volts. Honestly, I still remember that it's 3 divisions because you notice 1, 2, 3. It's a simple one. Last part, C. Deduce the value of the voltage UBC and name the used law. First question, am I given the value of BC? Is the value I calculated here, UAB, is it UBC? Obviously not. They're different. Second, well, how is the circuit connected? In series. What is voltage in series? Additive. Questions always roll the same way. So here we can directly say U, I'll move to this side so that you can see it in a better way. UAC equals UAB plus UBC. Notice, when you use circuit points, you can skip the idea of being in series. It shows itself when you write it like that. Now, UAC is given to be, if we go up, 12 volts. So 12 volts equals. UAB is just calculated to be 3 volts plus UBC. Now, if we simply do the math, UBC equals 12 minus 3, which is 9 volts. Okay? Frame the final result. Now, what do you notice about the lamp? Part C. Part 2, in fact, we just answered C. Okay? Part 2, the lamp functions normally. Why? Since UBC equals 9 volts equals U rated, thus the lamp functions normally. Okay? A note only concerning the thus. Okay? I've used this symbol. Maybe you don't know it yet. Okay? So the lamp functions normally. You can simply keep it if you know what that symbol means. Now, part 3, I won't take of your time anymore. Part 3, determination of the value of R. This is something not required right now. We are still in the lesson of DC voltage. We didn't move to resistors. Later on, when we go to resistors, you will be able to solve this easily as well. I hope that you didn't find this question hard. It is simple, straightforward, and it can measure your level referring or regarding the official exams. Don't hesitate to ask any question if you have about this lesson, and try to solve the exercises that you are assigned in the or attached beside this. Have a nice day, and thank you for your time.